Doerksen's Takeout box, Stereochemistry. What did we learn today? We learned that the relative 3D spatial arrangement of atoms affects all phases of drug action. There are three kinds of stereochemical isomerism that we're interested in for drug molecules. One is conformational. Conformations have to do with all the different low-energy structures that can be relevant for drugs, not only when they're on their own, but when the molecules are interacting with protein targets. Then, when we consider about conformations, we should think primarily about where there's a possibility of rotation around single bonds. Next, we considered about geometric or cis-trans stereochemistry. When there's a double bond or some other feature of the molecule that provides a point of reference, like a ring, a flat ring, then you can have substituents sometimes that can be attached in different arrangements relative to each other. So then we have to consider about cis-trans isomerism, and we have to be able to know how to assign E or Z for the arrangements of the substituents around that double bond. Thirdly, we need to consider about optical stereoisomerism, in which there's an asymmetric carbon. You have to be able to recognize where is an asymmetric carbon, one which has four unique substituents, not only looking at the immediate atom attached to it, but also at close-by atoms. And then we consider about how to assign R and S to the arrangement of the substituents. There are two different arrangements that are possible that are called RS. Once we understand about stereochemistry, then we should realize that there are profound pharmacological effects, that different stereoisomers can have different behavior as drugs, and these have important implications for health as well as for finance.